This video is a tour of the Berkeley Lawrence Lab in California. I want to start off by thanking Tom Lipton. If you don't know Tom, he runs Ox Tools, the YouTube channel. You should absolutely subscribe to his channel. Because he works there, he isn't always allowed to post stuff like this to his channel. So I want to thank Tom for both taking us on a tour and allowing us to post this video, but please check out Tom's channel, subscribe. He is a amazing amount of knowledge as a machinist, fabricator, and he's a really good guy. Read the Wikipedia article on this lab. This place is crazy, from the development of some of the original nuclear technology to, I think they discovered 13 of the periodic elements, to particle accelerators. I was totally blown away. I really thought we were going to see a couple rooms and maybe a few machines or machine shop machines, and what we saw was just mind-blowing. Multiple satellite machine shops, a centralized machine shop, some crazy technology, both in the machining side as well as just general fabrication and tolerances, and then the science is just amazing. So we kind of bounce around in the video, but sit back and enjoy. And again, thanks to Tom for the tour.
For the activities in this building, although this is probably one of the better equipped ones. A lot of them, we call them closets, really. It's a drill press and a little diacro brake, and that's a shop, right? But this one, we have a CNC mill and a bunch of lathes and some mills and whatnot. And some guys who run it.
Is it oil light?
That's 954 aluminum bronze, so we made a whole bunch of clamps out of that. So, It's a sliding gap bed lathe here. This is kind of a neat lathe.
The whole bed slides.
The whole bed slides.
Oh,
so you can open this gap up. So if you're turning a cylinder that was this long and large, and the stage screw comes out, so you can swing even more. It'll actually swing this right here.
Wow. Whoa. Base plate. Holy, that's oh my God.
Yeah, so we can put that in there and swing that. So
2,000 RPMs, baby. Let's go.
Yeah, right. Yeah, I'll take the day off when you do that. So.
Wow.
Yeah, this is an Argentinian lathe. It's actually it's kind of neat. I kind of like it actually, but the gearbox was invented by a madman, so it's pretty hard to. Yeah, every time I use it.
Look at all the list of cabinets. So jealous.
Samples, they cut some 8-inch aluminum.
Water jet stuff. Oh my God.
So that is stainless stuff. That right there? I think that's
stainless?
Yeah.
Oh my God. Tom's saying this is stainless. Wow.
Yeah. Oh no, I'm sorry. That's aluminum. That's aluminum. But they cut some really thick stainless for,
it doesn't even look like you've got crazy taper in it.
well, this has the dynamic head on it, so I can do the comp and the tilt and stuff like that.
Were you saying that you were going to replace your float pretty soon?
Actually, so these were some gear segments, right? And originally we were going to wire EDM these gear teeth profiles, right? And they had just gotten this new water jet, right? That has this tilt comp thing, you know, and exactly. So I said, hey, let's try cutting these direct, right? Just give me your killer, your killer edge quality and all that, right? All we did was bead-blast them and deburr them, and we used them. They were fine.
Way faster and cheaper than EDM.
Yeah, it is. And EDM is real accurate, but I don't know, there was 16 or 18 segments that had to get cut, so.
That's awesome. It's feeding in. Automated vertical bandsaw. You can see it moving in. Deep throat punch. Oh, so cool. Wow.
The riggers are in there. Must be moving that plate out of there. For measuring insertion device in there. Where's that? Oh, you guys are like this.
Thick plate, huh?
You have a little diagonal brake, right?
I got this guy.
You have this?
I have a 12
That's
inch.
a shear.
Excuse me, I have the shear and the finger brake.
You have these.
I don't have a slip roll. Never seen one.
Look at this.
Those are
Is
cool.
that cute
It's
or
cute,
what?
yeah.
This table,
like
I
this
would
guy.
love to have
Yeah.
this whole little
Finger
thing.
brake.
This is Playland here. So
New machine.
these are some of my tubes down there that they're working on. Wow. Those are what we cut the grooves that I showed you in.
Wow. Oh my God.
So actually, you like this. This is a very interesting configuration of the machine here. Okay, I can't open it. But this is a little decal DMU here. So it has, this table has the ability to tilt in 2 axes. It's got a little tool changer. And look where that table is. When you open this door, you're right there with
really
the
nice.
machine. It's a really nice setup.
Oh, that is nice, yeah.
And this is a very, very popular machine here. And
Heidenheim control. It's a motorized controller. It looks like
Yeah.
for the.
yeah, it is. And I'll show you the other ones that they use all the time here too that are also they're Mayhos, which is a really neat setup too.
The
This
same group, right? Decal.
Yeah.
Or,
Well, you know what? I don't know. I'm not positive. And but this particular one, I really like this configuration here. And let's look at some of their brag table over here. These are proofing parts and things like that they've run. Wow. We've got this NL here, which is live tooling, dual spindle, Morseki wood. They use some actually Randy was showing me these guys here. Woo! In titanium.
oh my God.
So did all this stuff, plucked it off, did the other side.
Self-spindled everything.
Yep.
Oh.
Full 9 yards, yeah. I don't know the story on a lot of these, so I just actually they did that on the NL too. That was a proofing.
Seriously?
part. Yeah.
Wow.
Yeah, O-ring grooves, all kinds of crap in there. So I think the real one was in. Hey.
Tom, I had a hell of a time getting everything to come out.
Yeah, proof the nose.
Piece of titanium.
Right.
But look how deep that is for radio live
I did my best. Let's say
Well, that's
that.
probably going to be pretty good.
So I'm just afraid to get
surface
slapped to
finish,
get
too.
this one.
Yeah, right.
That way.
And then I'll tap
Yeah.
these.
As long as I can get
This
bolts
guy.
through the holes, it's not going to make
How do you
much
keep that from
difference.
chattering?
Yeah, some of them it's like it was almost like the OD and the ID weren't concentric.
Oh, really? Oh, okay. All right, well, we're going to be putting that together in about a week and a half, so...
Now, I figured worst case scenario would
Heck,
probably
look at
have to
this.
pull the
How
whole thing together, bring
Swiss
it down
machine, that would be the easiest way.
Yeah.
clean up the
Right.
ID a little bit for you.
Or
Oh, yeah.
gnarly.
Yeah, we'll probably ignore the OD and just kind of
pretty cool.
shift everything so the ID kind of lines up because there's some sensors that poke into those little pockets. But there's clearance on them, so probably okay.
26 and put a 16,000 swing.
Monster, what's the problem? Are they done yet?
I'm gonna spin the main spindle and the live tooling to get about 9,500 RPM.
Oh, really?
Total.
Oh, so you could
double stack
double
it?
up, right? Yeah.
Yeah.
No kidding.
Yeah,
That's cool.
special.
26,000. Good
idea.
Yeah.
Oh my. Wait, is that the part? That's the workpiece?
That's my material. Yeah.
Chuck and a chuck and a chuck, right?
Yeah.
Right on.
Oh my.
So Randy's been. How's this load test? Oh. Yeah? Oh. Okay. Yeah, the stainless things you're working on. Okay. So this is the more modern version of that little one that we saw. The cable on this is all powered. So it does a bunch of stuff. The first guy that talked to was Brian. He runs this a lot. So, wow.
I guess, oh yeah, you can see your y-axis is actually only at the top there on those 2 linear rails, so it kind of
Well,
pulls.
it comes out and goes sideways, and then
Yeah.
this does this and then rotates. So
Holy
it's
cow.
a neat configuration.
How does mine move?
So this moves this way, and then this can move out. See the rails there?
Oh, okay.
So that can come in.
Oh, I see.
There's a little.
I was kind of hidden. Yeah.
I've never seen 246 blocks look small.
Yeah, no kidding, huh? Right? Those are 1, 2, 3 blocks. Hey, come on, bud. Oh, chicken shit little job. That looks pretty boring. Tool change, okay.
Yeah.
But
Makino?
look at that. You're right in the business here,
Yeah.
right? So this comes out, translates sideways, and then the table comes up and down. So, and then these you can operate these in.
Oh, it's like a tool room.
See that?
Side. Huh.
Manual, right?
Oh, okay.
You can kind of operate them as manuals. So
Yeah.
it's a neat configuration. Those guys can pull off to the side over here. So yeah, it's kind of neat. I would entertain one of these in my shop. It's kind of a nice versatile setup.
Yeah.
Open
Easy
format, right? To me, that's important for jobbing work, right?
It's always like leaning over stuff.
I mean, you look at that. You're doing this with the freaking holders, right?
Yeah.
And there's a big one over here. The 50 taper, you got to do that.
It's
right?
heavy. You can lift a 50 taper tool out.
The
3
40s
feet.
are heavy, right? The 50s are murderers, right? It's a young man's sport.
Wow. Wow.
So he's contouring all this stuff,
3D. Oh my God.
stainless, and then
Oh, stainless.
so these went through. We're doing some experiments with some thermal treatments,
Yeah.
and there's some different thermal treatments here. Some of these went through an annealing process, and some
Yeah.
went through a stress, and some went through a cryogenic stabilization process. So we're kind of evaluating some of those.
Yeah, you would think you would. Well, okay. So stainless, is that like a cold roll? When you machine it, it's going to move a lot on you.
It does. It work hardens as you're working on it, and as you remove material, it tends to move around. So here's the profile now.
Holy cow.
What's the cycle time for these parts?
Oh, I don't know. I have no idea. Don't really care. We just care that they come out right.
Yeah. Okay.
That's more of our need here.
Yeah, that's true.
So this is 1,600 millimeters X travel. So 1.6 meters.
Yeah. Wow. That is a large machine. Look at the counterweighted head. You can see the chain link.
Yeah.
So this is 50 taper, right? And I don't see any holders around, but they weigh a ton.
Yeah, I mean, you can see
Yeah, right. Just
Yeah.
everything just scales up.
Yeah.
You know? The wrenches, like you got stairs. You got to basically like
Climb into it.
climb in there to do anything, right? You know, I mean, it's
Look at the
not
size of
trivial
the.
junk, right?
That's more Lista cabinets than I've ever seen in my life.
Yeah, this is it.
Wow.
So we got a big boiler here.
Oh my gosh.
Pretty good size one there.
A Bullard vertical turning lathe.
Actually, this is small as far as bullards go. You know, I mean, but it's pretty big for us. So pretty good size.
Wow. That is so cool. Look at the, yeah, so that you got the counter pitch screws. You pull it in. Oh, so can it pinch turn?
You can cut inside and outside simultaneously.
Yeah,
with this,
yeah. Okay, wow.
So, and you can, let's see.
That's
yeah,
rad.
and this one, or both of them, you can swivel them. So you can cut tapers, inside taper and outside taper simultaneously. So,
And it doesn't look like anybody's crashed into the truck.
yeah. Yeah, this probably hasn't seen a lot of use.
Yeah.
And, actually, I'll show you my favorite lathe up here.
Wow, look at the granite block. Holy cow. Oh yeah, there's a 50 taper.
Yeah. Workout. Change it.
The motor for the turning lathe.
There's a boring bar. Petey was using this lathe here to work on my tubes. And, hockey shifter there, yeah. This is my favorite lathe here. This is a French lathe. It's a Cazeneuve. But it's this A really, really nice machine. It's well laid out. Speed controls, you can shift the speed real quickly. It's just got some small features that are really kind of neat, you know. It comes graduated like that.
Oh, yeah.
The hand wheel layout's real nice.
Smooth spindle, holy cow.
It's got a tooling slide on it here, which means I can loosen this up and I can take this upper section and I can push it over on the other side, which is kind of neat. Turn counters here.
Whoa. Never seen that.
And then there's some neat stuff on the tailstock on this. So it's got a little pointer here that you can extend.
Oh, wow.
And you can actually adjust taper here.
Huh.
Oh, yeah.
It's just, they really thought about what the operator needs, right? Yeah. And they just built it into the machine. And this thing is it's very well made.
So support for the screw, huh?
Yeah.
That's cool.
Yeah. Foot brakes, you know.
Yeah.
Oh, yeah.
Speed controls right at your hands, right? It's a sweetheart.
Oh, 6-jaw chuck.
Yeah, I would. Lots of details on this. I mean, look at this.
Yeah.
It's got a traverse dial there. You know, this stock. I mean, they got a DRO on it, right? So
right.
You don't really need that, but in this case, it's pretty neat, though.
Yeah. Savannah River plant. Just incredible.
Everything gets bigger. These are the angle plates that go on this one.
Oh my God. Those are the plates. The whole thing.
Those are angle plates. It's already on there.
Oh my
that
God.
weighs almost 4,000 pounds, that angle plate. And I think, this is a 60 taper on this one, I think.
Oh
60
my.
or 50, I can't remember now, but they're big.
Is this a horizontal boring machine?
Correct.
Yeah.
Horizontal boring. Now this one, they want to get a new one. This one's pretty old. And the spindle speed's kind of low on this one. They want to get one that they can do like 10K RPM and stuff.
So that's your only spindle right there.
That's it, yeah. But what it does is that can extend 40 inches out. So it has a column that basically you can feed out and you can reach into holes or things like that. You can put a rotary on that. They got a giant rotary cable they can put up on it.
This is not a jig boring machine.
No,
that's
correct.
a different machine. That's different, accurate. These are accurate, but those are more accurate.
And this is, I think this is about 10-foot travel on this. And you go through some basic safety training. You can kind of come up here and you can use these machines. And if you want to just do the work yourself because you want to save money, or you need something really quick and the main shop can't get to it, so you can go in here and use it. Steve kind of works in here. Normally he does what they call quick turn machining, and if he can't do it, then you can do it yourself if you've taken the safety.
If you're a scientist, you're doing research, you need a part made, and you submit the drawing or that part to the shop. How do they account for like the plan?
This is where all the really fussy stuff is made.
Wow.
And this has been here for, I don't know, 10 years or something like that. Yeah. And then we just got this guy over here, which is the fancy pants one. So, well, they're both fancy pants.
20,000 RPM spindle.
Yeah, this one's
40?
40, yeah.
So, yeah, this one, they're both about the same accuracy. It's just 3 axis on this, a little more tail move. This is a 5 axis, got trunnion moves, and twice the RPM.
40K 5 axis.
Yeah, and when it's running, you can't even hear it.
Yeah, it's actually kind of on.
Is it? Oh, wow.
40K 5 axis. The spindle's on, we can't even hear it.
Turn it on now. So there's that's his big face mill. Video tool inspection thing. Can you show that, Brian?
Let's see if I can remember it.
HSK holders balance up to 60K. Good crazy. You should bring over the new edge finder you're making that you use on this machine.
I think it would blow up. It would blow up in this one. I don't think he has a holder big enough for a 3/8 shank, so that's the scary part.
Yeah, this one, 3/8 is as big as I can go.
Is it? Yeah. No kidding, 10 millimeter? Oh, man. So this machine was installed, I don't know, a couple months ago, and they're just, kind of testing it out and doing it. It replaced the machine because it couldn't produce the surface finishes they were looking for. So, as milled finishes, they were down in the 4 micro-inch range, actually, as milled. As milled. They looked almost polished, right? And, so this is tarnished now, so that is kind of an example of that's as milled. That isn't.
It's tarnished, but
it's tarnished from people touching it and all that, but. You can kind of see it.
It's a good surface finish.
It is, yeah. Well, they make some electrodes and things like that that need a good finish, and you can't do anything after it's done. It's so fragile, it's so small.
So you mean like a sinker electrode?
What's that?
Like an EDM sinking electrode?
No.
Oh.
I mean the actual part.
Actual part, okay.
Something that you can't sink or wire cut or whatever.
Got it.
So,
What would be a typical feed rate when you're doing like a finish pass on a part?
Depends on what it is. Like Tom was saying there, some of these tools are diamond tools and that where it's just rubbing it off. We're just doing tenth at a time.
Yeah.
Yeah, he might program a 2 or 3 micron depth cut or something like that.
It'll come over and do a general pickup, and it's just finding a general length. It's going to come back up, go over the tool, the nozzle behind it, blow it off with air, do a little dance, then come back and do a measurement. So you'll see a blink here. That gap right there is about 2 thousandths, 50 microns. So 4,000, that's your hair right there, hair width.
Okay.
Human hair width.
Whoa!
That's the tip of that little tool I just showed you. It almost looks flat there, so that comes back, blows it off.
So yeah, any dust that it picked up or anything like that.
So yeah, first one's just an estimate, where am I at, so I can do a dual dance over there, and then it comes back over. And this is just a drill cycle, so it's coming straight down, but for like an end mill and that, I can check the radius on the end mill, check the flutes and everything.
Quite the blowing cycle.
You guys have different options on this.
It's the end mill spa treatment.
Yeah.
So that's the most of the dance it'll do, but you can actually separate it out.
Going in, comes up on the screen. So there's the tool.
That's the tip of the tool. Well, it's going to come back down. That was a bit. So there's speed right now.
Wow.
Is it a drill or an end mill?
That's a center drill. That's a number 1 at that.
This is why you like wire EDM.
This one's kind of neat too, because on one side it's a 1, on the other side it's a little Mitsubishi.
It's a loft.
Wow.
Yeah.
Actually, it's supposed to go in like that. So
Yeah.
Wow.
Yeah, they use the wires a lot up here. We cut a lot of weird materials. They shape magnets. They cut all kinds of different profiles. Very hard to do. Don't knock it over, Tom.
Wow.
So this little...
Yeah.
Pretty... There's one in here. Let's see, where is it? No, I don't see it. I wonder if somebody...
Somebody sneezed and...
No, there was one that had a bunch of little holes in it that was kind of cool to look at. Oh, there it is.
Oh my God.
Yeah.
Whoa.
That, yeah.
30,000 RPM spindle. Oh my gosh.
So I think that was done on the Mitsui Seiki that we had before the Yazda. So, but here's a neat one. Look at that.
Wow.
It's monolithic. It's a single part.
Single part?
Yeah.
Huh.
Pretty crazy, yeah. Walls. And then here's my favorite door.
Oh my God.
Jeez.
Oh my God.
Is that like full of lead or something?
Solid steel.
Solid steel.
This was all built for LBL, right?
Yeah.
So why?
It's radiation shield.
Yeah.
You see this plate right here? On the edge? Oh,
Sorry.
Go ahead, push on it. You get a sense of the inertia.
Yeah.
Oh my God.
Yeah, when I came here, I was playing with this thing. I go, oh, this is really cool.
Oh my gosh.
Wow. It moves slowly. Look at the yeah. Look at the. Holy cow!
Wow. Test area.
Control room for the magnet test area.
And this would be a typical magnet that we would. Actually, this one was tested here. So this is a superconducting magnet, and this is a dipole, which means two poles. And this is, I don't know, 6,000 pounds, something like that.
And this has to be chilled in order
That
for it
has to be chilled down to 4 Kelvin to get it to work. Right?
What part of it exactly needs to be 4 Kelvin? Is it
The whole thing.
the entire thing?
The whole thing, yeah. So it's very interesting, actually. So these are the leads here,
Yeah.
okay? And we put something like 18,000 amps in this. Okay?
But you can do that.
Yeah.
At 4 Kelvin.
At 4 Kelvin. Yeah, you can't do that
And
at room
only
temp.
at 4 Kelvin.
And only at 4 Very good. Excellent. You're learning. So-
0 Kelvin is like the unobtainable, right?
Exactly.
Okay,
So that's absolute zero. But we go down to about 4 Kelvin. And so what's interesting here is this magnet, it wants to fly apart, right? It wants to blow up and just come apart.
Yeah.
So we have to keep it together. We have to contain it, right? So this thing is actually, in its current state right now, it's preloaded, okay?
Okay.
Now, on top of that, you see it's got an aluminum shell, right? Now, you guys know a little bit about thermal expansion, right?
Yeah.
So what happens to that aluminum shell when we cool it off? It gets smaller, okay?
Increases the preload.
That's right. Excellent, yeah. And it shrinks more than the steel structure, okay?
Sure.
So now here's a sense of how much preload is in it. That changes diameter by about 200 thousandths. So
How does it not? At room temperature, wouldn't the aluminum crack? Is it does the 4 Kelvin?
it's hoop stresses, okay. So it could take it, okay. And interestingly enough, so the strength of the aluminum goes up sharply at cryogenic temperatures. Okay, and the modulus changes, and then a bunch of things change. Right?
Yeah.
It's physically stronger and stiffer, right? But that shrinks by 200 thousandths. So
Is
it
it-
preloads it even more.
Yeah.
Yeah, it preloads it even more. So when we build these magnets, we have a special system of keys and shims that we put in there. So we use hydraulic bladders, and we pre-stress it, then we slip shims in it. And there's instrumentation that tells us how much preload that we have on the magnet, right? And then we balance it all out so it's nice and even at this initial preload level. And then when we cool it off, we get the real preload.
Yeah.
And then it cools it down even, or it shrinks it down even more. So
Is it a household grade of aluminum?
yeah, I think it's a 6061.
It is.
Yeah.
So, do a lot of these gaps in here, do they disappear whenever you...
No, those don't actually. So these are load pads here. So you see that's a shim in there. So now here you can kind of see the radius of this thing.
Wow. The railroad ties running around it.
So there's a polar crane that runs around this. And what you see down here,
Polar crane.
blocks, these are shielding blocks, radiation shielding blocks.
Oh.
So when they service the machine, they pluck those blocks off and take them off to work on things.
When you go to your first particle accelerator, you always want to find the Girl Scout cookie flyer.
Oh, right, yeah, exactly, right. We don't have any Girl Scouts here, though. Just parents of Girl Scouts, right?
Yeah.
So we'll cruise around here and see what we can see.
Oh my God.
So this is just one little branch line here, and this starts to give you an idea of the complexity of this machine, right? And this is probably actually a simple one. So everybody asks about the aluminum foil, and so this is an ultra high vacuum system, okay, 10 to the minus 11, something like that. So a lot of these are baked, so they're hot. Okay, you feel the heat coming off of this thing.
Yeah.
So these are wrapped with heater tapes and whatnot. The aluminum foil keeps those heater tapes in contact with the components. So it's to drive off any moisture and things like that. So the aluminum foil is just convenient to kind of hold that stuff on.
Is it
looks
literally
weird.
just
It looks weird.
household aluminum foil?
No, of course not. It's fancy foil, so.
It costs 4 times as
Yeah,
much.
it's UHV foil because that's what we have. It comes in these big rolls. It's heavier. It's really nice, actually.
Yeah.
So yeah. But we wrap all the parts in it, you know, after they're cleaned, and you got to. Yeah.
Tom has been showing a bunch of these different 6 struts that are pretty incredible for stability and able to level in, but then you have to laugh at the 12-volt drill with trigger actuated solenoid.
That's pretty awesome, actually. So yeah, it's a little gear motor.
Oh, gear motor, sorry.
Oh well.
Beautiful stuff. I mean,
I haven't taken the training how to run that yet.
Yeah.
So. But yeah, there's another 6 strut, kind of a long axis one.
oh yeah.
On this.
Holy cow.
Oh, what's really cool is they're totally scalable, right?
Yeah.
And
Oh, another
you
one.
can see them everywhere. Any dimension they go.
It's like they go on everything here.
We use the hell out of them. Yeah.
And it has nothing to
They repurposed a Bridgeport mill there.
Let's play Find the Bridgeport.
And it's all servo control. But if you think about it, so the requirements of their job here was they needed a big, heavy platform that could move in several axes, right?
Right.
Well, certainly you can build that, or you can just, hey, this
Yeah.
thing's already made, right? So, and then they
Yeah.
kicked it up on a little sign plate there, a big sign plate, literally. And,
Yeah.
and so now that thing can extend and contract, and they have a rotary axis on that.
Oh,
particular one.
they really are using the servo on the X. Hilarious.
And so you can just barely see it. That there's a rotary axis there too, so they can manipulate a sample in there and kind of rotate them around. Here's another one.
It's got a DRO.
Yeah, right. A Sargon, no less, right? Yeah, that's an old one. And here's another one that has some rotary axis on it. The word gears there, so they can take a sample and they can rotate the sample on there.
I love how that you don't even care about that sort of a granite plate anymore. Like that's not even eye-catching to you.
No, granite. Yeah, we got a lot of granite around here. Yeah, we got. In fact, truly, we have a granite graveyard. So this is where a lot of big things get put together in here. And it's kind of a flex space. So if I have a project and I got to put some stuff together, I can kind of not lease, but I can ask for space up here. This is cool that this is here. This is an undulator, okay? It's an insertion device, so it's got permanent magnets in it, so we don't want to get super close to it. But basically, it's like a really fancy press brake.
Yeah,
Okay. But it's got permanent magnets in it. So what they do is they shoot the beam through that, and the permanent magnets, the fields alternate. So the beam does this, and as they cause the beam to bend, it emits synchrotron radiation out sideways. So there's a bunch of some things that look like this up at the ALS.
And this will go in the ALS.
No, actually, this is they're building a bunch of these, and they're going to go down to Slack for installation down there. They're supposed to build 20 of them or something like that. So. But yeah, all that's basically
incredibly
for
thick.
Yeah.
Holy cow! Look how thick that is.
And it's on the 6 strut again, so.
Oh yeah.
Big heavy one there. Yeah, they're trying to hold. Runs this big nice CMM. Wow. That's right. We try. We'll try real hard. So that looks like ceramic to me. So let's do some kind of inspection on that. And oh, so you're gonna go over the surface of that? You're looking at flatness and stuff?
Well, compare it to the CAD model.
Okay.
Freeform surface.
Is that gonna
Really?
curve or is it flat?
Oh yeah.
No, it's got.
Oh, it's got a crazy
Does it?
curve.
Oh yeah,
It's such a
can see it
flat
from the-
material.
And
Look.
then what they're going to do is they send it out and get it coated, and then it comes back and I remeasure it again, which is why I've marked Y minus and Y plus holes for alignment for rotational alignment.
do you know what they're coating it with?
No, I don't, Tom.
Are you gonna be able to touch it after they?
I had to put it up with surgical gloves anyway.
But you're gonna touch the surface. Are
Oh,
you
with a
scan-
touch probe.
Yeah.
No, I still touch probe like I'm doing here now.
Okay. All right. So you'll touch
So
it.
this is right here. Oh yeah. See,
It's
that's
literally
where the air
it's
comes out.
literally the game. It's just
Yeah, it's just like an air hockey
Then-
game.
yeah,
That's
yeah.
all it is.
Right.
Just like.
So granite columns with air bearings to give this thing just bonkers
This is the old one here.
precision and not affected by.
They use this now with the Hall probe for measuring magnetics.
How's this running now that they did all their work and calibration?
We found out the y-axis has a
Brake and
Tool repair. Totally self-sufficient. Fix their own stuff. Look at all the belts.
they started rebuilding at Bridgeport here. They started scraping it and stuff, but they got sidetracked. And yeah, I mean that's the kind of stuff they used to build machines from scratch up here. So literally, yeah.
Yeah, there's the table. Wow.
But like I said, you know, we throw away some incredible stuff. I always look in the scrap things. You never know what you're going to see in these things.
We're looking at a machine that makes flat wire for the magnets, and it feeds the spools out of there. We've been sitting here for about 5 minutes when they explained that it's actually made out of an old Axelson lathe, and sure enough, if you look down, there's the bed.
So
and the cross slide.
John, cruise around the other side there, and you can see the headstock when you go around that corner there, and kind of see the backside of the blade.
Oh my! And it's just on a chuck.
And all those chains on the back, they look sort of root gold-ish.
Yeah.
But they,
Tiny.
each of the wires gets a twist.
Oh.
It's like making rope or wire cable. You want to put a torsion in the wire so when the final cable is assembled, the back torsion, the release of that torsion helps to lock it together.
Just like when you roll an extension cord, you roll the
Yeah,
thing.
so you got to take the twist
You
out.
preload it in one direction.
Yep.
No
So
kidding.
Hugh gets pissed when I got to turn a shaft and take all his setup out of the lathe, right? Neckings here. Okay.
Is it an initial necking?
This is an initial necking. All right. So
This is the
this
wire.
billet starts out, I don't know, it's about 3 feet long, a meter long or something like that.
Yeah.
They heat it up and they scrunch it through some dies.
Yeah.
Okay, and this is like an initial necking down to 3.5 inches or whatever. And you can see the filaments in there.
what's the
I didn't realize it was.
So those are filaments.
Those
Those
get smaller and smaller and smaller.
yeah, okay, so this just gets totally cool, okay?
Okay.
So this it keeps going through a successive smaller and smaller, smaller and smaller openings till it gets down to that 1 millimeter.
The
diameter.
wire and the spools.
The wire and the spools
Yeah.
that we saw.
So it's layered wire.
Yeah, now so you saw that, right?
Yeah.
Remember this pattern.
Yeah.
We're going to see it again at 1 millimeter. Because those are 1 millimeter wires.
This is a cross section of the whole
cable.
wrap.
Okay, but you can see that pattern that's still there.
And that's where they've crunched. Well, maybe that's just a.
Well, that's
Pictures.
distorted from
Yeah.
the making of the cable. Okay.
Wow.
So this is copper on the outside, and then these wires.
It's niobium titanium.
Oh, niobium.
So there's like $180,000 worth of wire on that lathe
Yeah.
spindle right now.
Don't quote me on that, but something like that.
You've been quoted. There's the wire in its flat form.
Giving a couple guys a tour here. This is Tom Johnson. He works in the
Composites.
composite shop here, and a lot of what they do in here is detector parts that go into CERN. And so these guys are world famous, man.
Stanridge granite right there.
Yeah, all over. So here's a part of a detector structure that they may feel. This is pretty heavy. Watch out. So what they want is these very, very lightweight, stiff structures for these detectors.
Oh yeah.
The granite graveyard. Does this still? Does some of this stuff end up on like gov liquidation?
Occasionally, yeah. So although surface plates not so much, we tend to keep them. So what happens here is power goes in here and is stored in very large capacitors.
Oh, wow.
We send a very quick pulse out to the beam line. So yeah, we're going to walk down there. So.
Tom was telling us that this cabinet has rounded corners because it's such a high voltage. What would you say, 40?
40,000 volts.
So that way it doesn't arc into the corners, and the cage is just to keep us humans away from it. Really cool.
This is a grounding hook here, so before we go in there, we have to use this grounding hook to discharge any stored energy.
Just like the bracelet I wear when I solder a circuit board.
Yeah, right, exactly. Except this is a little, this is more like light protector. Themselves, these are ferrite cores in here, and the very heart of these things is a solenoid magnet that we wound actually. So we took all these apart, we cleaned them, we wound new magnets, installed new magnets, and aligned the magnets, and then put the cells together, aligned all the cells. It was a huge job. It's an $11 million job. So
Just this.
well, the whole machine.
Yeah. And these are on linear rails?
They're on linear rails. That way we can track them and separate them.
Oh, got it.
And insert, because these are tuned. There's some tuning with these, so we may want to drop another one in that has motors about that
Oh my God, really?
Yeah.
What's the bearing? Is it air bearing or something?
It's magnetically levitated, so it's not touching anything. So,
Damn. Do you do all your balance? Do you do all your balance?
Oh no, yeah, we don't.
Oh.
We don't do that over at the shop over
Okay.
there. So there's special folks for that.
Okay.
This is not. You cannot feel any motion, and Tom was just telling us that this is a magnetically levitated
Turbomolecular pump. Yeah.
turbomolecular pump that is currently at about 50,000 RPM. So is this thing on right now?
No, we're doing some maintenance on it now, but we maintain the vacuum system while it's.
Oh,
That's pretty fast time thing.
Yeah.
So you spread it out, it's not that impressive. But
Yeah.
it sounds great at a megawatt in a millisecond, right? So,
Tom is explaining these are the power leads to feed the magnets, and there's a panel for this room that's 4,000 amps at 480.
yeah.
And those things could dump or do dump.
Each one of these is a megawatt in a millisecond. That's the pulse intensity.
And you can sort of see where they crimp into or the connect into the power up there. And then this is just basically power supplies.
These are the pulsers.
Okay.
So yeah, these are the pulsers.
Oh, with the big caps that dump.
So exactly.
Right.
So that you can see the cables going through there, and they go up to these pulsar racks here.
Can you hear the caps dump?
Yeah, it's funny because I was all excited, when the first time they fired the machine and it goes click, and everybody goes, oh yeah, right on, and I'm like, what? Where's the sparks? Where's where's the laser beam going through the wall, right? I don't see anything, right? Click, and they're all happy, right? So it's kind of a letdown a little bit at that level, right? But to see the businesses all happy and everything, that's the best for us, right?
Yeah.
You work hard on this stuff, and then you see those guys go, yeah, right on, and it's pretty neat.
Yeah.
What's going on in there?
So this is a linear particle accelerator. So kind of like the one you see on TV, but instead of loop, it's linear, and then here's the target chamber. Oh wow!
We're all sensitive.
Yeah, well, there's some manipulators in there, and then those little helical things are they're plasma dissipators and physics stuff, man.
Could you stand here and watch it when it hit? Is it safe?
Yeah, you wouldn't see anything.
Yeah, there's nothing, right?
Yeah, so in here is a straight camera, so these events are very, very fast. And in fact, the pulse length is 70 nanoseconds, which is not much, okay? And it's faster than that. But there's a street camera under that catches these things, and so that they can study them later on. So what this alignment system allows us to do, it gives us 6 degrees of freedom. So we can raise and lower it, we can tilt it, we can translate it in any axis that we want. So it's kinematically, it's a kinematic knob basically.
Oh, okay.
So it allows us to align all this stuff very, very carefully, and it's super simple. It's just made out of rod ends and tubes basically. And it's scalable. So here's another one here, there's a little one here.
Oh yeah.
And they're much more intuitive to adjust than like this, which is a hexapod here, right? Okay. Hexapods are very, very stiff and stable, but they're kind of difficult to adjust manually. You need to adjust them with some kind of automatic system that does all the
calibrates.
Yeah.
Right. There's some angles involved.
Yeah, but the 6 struts, it's very stable, it's very simple, and it's a great way to basically get any kind of alignment that you want. So.
We were playing with a 3+2 Haas VMC yesterday trying to get the vise dialed in, and it was funny because the vise was supposed to be self-centering and it wasn't. And I was like, well, if we move it 7th thou this way, then we're going to automatically lose our. It's iterative. You basically keep going back and forth.
Walking around until you get it, right? Yeah. This is a. So here's the injector that we looked at the other end here, and then here's the target chamber here, and these are all the cells. And this is what the pulse looks like, as it comes off of the source, and then they start shaping it as it goes through the cells. And this is elapsed time, 400 nanoseconds, 1250 nanoseconds. So the pulse, like I said, it's kind of it's a spray coming out. Then we start shaping that squirt, and as it goes down, and then bang.
Good morning from a beautiful view atop mountainside here in Berkeley. We're actually about to go visit Mr. Tom Lipton himself, but we saw this view of the San Francisco, I guess, is this the bay?
The San Francisco Bay.
Yeah, and just stunning. Unfortunately, it's a little foggy, but you can, let's see if we zoom in, can you see the Bay Bridge and Alcatraz?
Yeah, it's the Golden Gate.
Sorry, Golden Gate, that's right.
That's the Bay Bridge.
Bay Bridge over there on the left. That you can definitely see. But I mean, breathtaking. It's beautiful up here. Really cool.